All right, guys, get ready for this. We are going to not only see all of the paper, but we're even going to turn it so that we can see the computer screen too. We're getting super high tech here. Let's begin with the practice check from today. So we've got the problem, Palmer drew a plan for a game room at a scale of 1 to 60. On his drawing, one side of the room is 2.5 inches. What is the actual measurement of that side of the room? So, if I know that the room is, let's start with the drawing side. So in the drawing, we know that it is 2.5 inches. I want to know what it's going to be actually. Well, I know that the scale of 1 to 60 would be a scale factor of times 60. So here, I would want to multiply by 60. 2.5 times 60, well, 60 times 2 is 120. Half of 60 is 30, so altogether I'm going to have 150. So that's going to be 150 inches. Now in feet, 150 inches is how many feet? Well, we know that 1 foot is 12 inches. We know 2 feet is 24 inches. We can keep scaling like that. Scale factor seems to be going this direction. You're multiplying by 12. And then if you wanted to go backward from 12 inches to 1 foot, 12 to 1, you would need to do divided by 12. So then if I have 150 inches over here, I know that I'm going backward, so I need to divide by 12. 150 divided by 12. 12 goes into 15 once, so I've got 4 twice, 6. So 6 out of 12, or I could pull down and do that. I have 12 and a half. So this would be 12 and a half. And then I had a bonus. If he made another room at a scale of 1 to 12, would it be smaller or larger than the first drawing? How do you know? Well, a scale of 1 to 60 versus a scale of 1 to 12. If it's 2.5 in the 1 to 60, then it was going to be 150 inches. If it were at 1 to 12, then 2.5 inches, I would have a scale of 12. So I would need to multiply it by 12. 2.5 times 12, well, that's just going to be 30 inches. I feel like I'm doing something weird here. We're going to revise. So we have a scale of 1 to 60, and we have a scale of 1 to 12. Okay. So in something that is 1 to 60, if I had something that were in real life, let's say 60 inches. If it were 60 inches in real life, going this way, it's times 60, which means that going back, we need to use the inverse operation and divide by 60. 60 divided by 60, that would be 1 inch in the drawing. If we took the same thing, it's a 60-inch wall, and we divided, the scale factor here is times 12, so to undo that, we would need to divide by 12. Now we would have something that is 5 inches long in the drawing. Well, it's only 1 inch long in the drawing here, so that wall might just be like this. Here, it's 5 times that. It's 5 inches. So at a smaller scale, we have a larger drawing. And that was something that we looked at a couple days ago. All right, so that was our practice check. Here, for people, we had a lot of people who were still wrapping their minds around this idea. Basically, how many centimeters are in a mile? We talked about using a process of elimination. because we know there are 2.54 centimeters an inch, 12 inches in a foot, 5,280 feet in a mile. Centimeters are small, miles are very large. So you're not going to have a small number of centimeters. It's going to take a lot of centimeters to make a mile. That tells me that something like this, where you are doing 1 divided by a large number, which would be a very small fraction, that cannot be right. We also know that when we're talking about scaling, we're talking about multiplying and dividing numbers. So adding them together, that does not feel like that's going to work here. So we're left with our multiplication and division. And I counseled people to consider it this way. You want to know in centimeters. You want to get down eventually to how many miles there are going to be. So let's start with how many centimeters are in 1 inch. We know from up here, 2.54 centimeters are in 1 inch. Well, then let's go to 1 foot. To get from an inch to a foot, we have 12 inches in a foot. So that tells me then that here I would have 2.54 centimeters each inch times 12. Now, to get to a mile, how many feet are in a mile? 5,280 feet are in a mile. So over here, I would have to take all of this, 2.54 times 12, and multiply that by 5,280. And if you look over here, you'll find that there's only one where everything is being multiplied. Order doesn't matter. 5,280 times 12 times 2.54 is going to be the same as 2.54 times 12 times 5,280. Then we looked at a card sort, and I'm going to show you what Michaela did. She worked alone. She was my only loaner today, and she did some really solid work on her own, so I wanted to show what we've got. I'm going to show you a set, and then I'm going to write it in here and talk about it. So first, we have 1 inch to 1,000 inches, 1 centimeter to 10 meters, and 1 millimeter to 1 meter. So I'm going to write these in here as equivalent scale. This one is fairly straightforward because they have the same units. Because they have the same units, we can say, we are just multiplying by 1,000. So then the trick is figuring out, do these also have a relationship of, to 10 meters. Do these also have a relationship of times 1,000? So for 1 centimeter, there are 100 centimeters in a meter. So that would be 1 times 100. That would get us to 1 meter. We have 10 meters, so we would need to do that times another 10, and that would give us 1,000 centimeters. So 10 meters is the same as 1,000 centimeters, which puts us back up here where we can do times 1,000. Down at millimeters, there are 1,000 millimeters in a meter, so you can rewrite this as 1,000 millimeters, and then getting from 1 millimeter to 1,000 millimeters is going to be times 1,000. So that's 1. Let's do 1 foot to 1 mile and 1 to 5,280. So 1 to 5,280, we have a scale factor of 5,280 because 1 times 5,280 equals 5,280. 1 foot to 1 mile, we need to get them to the same units. Because if we just did 1 times 1 is 1, that would be saying that these two things are the same. When we talked about scale copies, if you had something that looked like this and an identical one, that would be times 1. But feet and miles are definitely not the same. 1 foot is not the same as 1 mile. So let's convert this. 1 mile is the same as 5,280 feet. To get from 1 foot to 5,280 feet, you would do times 5,280. So that's the gist of what we did. We can see she had more than this. She also had her inches to feet. She also had centimeters to kilometers. But it really comes down to always getting them to be in the same units. And so to make sure that sets were equivalent, you want to ask yourself, sorry, that's my new fountain, actually, inside garden, which is making a lot of fountainy noise right now. Do they have the same scale factor? And in order to do that, you need to get things that have the same units, like inches to inches, or centimeters to centimeters, or meters to meters, because then you can just compare how do you get from one to the next. This bonus we didn't talk about in class, but the idea of which scale is going to produce the smallest drawings. Well, as we saw in the practice check, the higher the scale, so for example, 1 inch to 20 meters compared to 1 inch to 10 meters, that meant the higher the scale, the smaller the drawing. This was smaller. Excuse me. This was smaller than this one was because an inch got you 20 meters, so it didn't need as big of a drawing as this one. So if we were looking at what we've got up here, 1,000 compared to 5,280. 5,280 is a much bigger scale. So since 5,280 is larger than 1,000, this is going to produce a smaller drawing. Get a smaller drawing. Over here, I talked about some ways that we could use tables to organize our thinking with conversions, because once again, we can get to a unitless scale if we have the same units. We cannot do that if we have different units. This is not the same as 1 to 15, because 1 centimeter times 15 is not 15 meters. So let's look at that, what that does here. If you have a scale factor of 1 centimeter to 2 meters, I'm going to label these as left and right. We could also label it as scale to actual, but in this case, just to keep myself, you could also say scale drawing to actual. I'm just going to label them left to right. So to get from the left to the right, we have 1 centimeter to 2 meters. I want to get these into the same units. I'm going to go for centimeters since I know that then I'll have some large whole number. I have 100 centimeters in a meter. So for each of my meters, I'm going to have 100 centimeters, 100 times. So now I have the scale 1 centimeter to 200 centimeters. I'm in the same units, so I can look across. 1 times 200 is 200 centimeters. So my scale factor is 200. Here, I have the scale. I'm missing some information. So if we're going from left to right, we know that if we're going from 1 to 60, that's a scale of times 60. So that would be like saying 1 inch, what times 1 times 60 is going to give me 60 inches. Now I just need to get that to feet. I know that there are 12 inches in every foot. So if I have 60 inches, I want to cut that down. If I have 12 inches, that's 1 foot. If I have 24 inches, that's going to be 2 feet. If I have 36 inches, that's going to be 3 feet. If I have 48 inches, 4 feet. 60 inches, ooh, bingo, that's going to be 5 feet. I can also consider that as divide by 12, because there are 12 inches in a foot. 1 inch is going to be 5 feet, and that puts me in the format that I've been asked to solve for. Then down here, we have a scale of 1 to 2,000. That tells me that my scale factor is times 2,000. So if I'm going from 1 centimeter to some number of centimeters, oh, they're the same unit. That's nice. So I can just do times 2,000. Now I have 1 centimeter to 2,000 centimeters. It's the same scale down here, but I just need to turn it into meters now. Well, if I know that I've got 2,000 centimeters, and there are 100 centimeters in a meter, and I'm working down, because I know I'm going to have fewer meters since they're bigger, I can divide by 100, and I'm going to have 20 meters. And then, looking at 1 centimeter to 20 meters, I want to know what would 5 centimeters be if I scaled up. Well, 1 to 5, I can just do that 5 times, like we also kind of talked about up here. 1 centimeter would be 20, so 2 centimeters would be 40 meters. 3 centimeters would be 60 meters, so on and so forth, times 5, I'm going to be at 100 meters. And then, this is a shout out to Nikayla, because she said, hey, I went and I watched your video, and it actually helped me because you told me about some of the homework. So, let's look at this. I want to complete each scale with a value that makes it equivalent to, the scale of 1 to 2,000, the same thing we were talking about in class. So I want to get from 1 centimeter to some number of kilometers. Okay, kilometers might be new to us. I said here that there are 1,000 meters in a kilometer. Looking at this then, I know that my scale needs to be 1 centimeter to 2,000 centimeters because we have the scale factor times 2,000. I know that that's the same as saying 1 centimeter to 20 meters. Now I need to get to kilometers. Well, there are 1,000 meters in a kilometer. I'm going down in number because kilometers are bigger, so I'm going to have fewer of them. So I'm going to divide this by 1,000, and I would have 1 centimeter to 20 over 1,000. I could also say that's 2 over 100, or 0.02, or that would also simplify to 1/50th of a kilometer. Okay. In this one, think about the fact that you have the same units. You have the same units and your scale is times 2,000. What are you going to be able to do? Okay. Have a great night. I will talk to you tomorrow.